the skill building, we're going to look at double integrals over non-rectangular regions. And here's the first question. That's what they look like. Do you notice that the limits of y are not numbers, or at least one of them isn't? It's y equals 1 to y equals x plus 1. And then you have a function, and then in this case, y first and x second. Now, the process of evaluating these is not too dissimilar from what you did before. So x goes from 1 to 2. You integrate this with respect to y. Well, with respect to y, you add 1 to the power and divide by the new power. And then you evaluate it from y equals 1. Question? No? Okay. So y equals 1 to y equals x plus 1. And then you basically substitute in. So let's see what we get. We get an x squared, x plus 1 squared. Take away an x squared times 1 squared. That there is just going to get me a minus x squared. And it's not uncommon that you have to do some algebra. If it's polynomials, there's a very good chance you're going to be foiling and distributing. And would you agree that if I want to integrate this, it's probably a good idea just to distribute the whole thing out? So if you take care of the x plus 1 all squared part, you get that. If you then distribute through with an x squared, you get an x to the 4. I guess technically you would get 2x squared, but if you take that one away, it leaves you with 1x squared. And then you have an x. Oh, yeah. Rewind that. This guy times this guy gets you 2x cubed. And then you'd have an x squared. Take away that x squared, which basically gets you nothing. And dx. So let me double check that. That times that is x to the 4. That times that is 2x cubed. That times that is plus x squared. Take away an x squared, cancel out. You're left with this. And this is power rule again. Evaluated at 1 and 2. So what's that? 1/2, 2 to the 5, plus 1/2, 2 to the 4. Take away basically 1/5 plus 1/2. And since we want exact values, we probably should be looking at letting the calculator do this now. So here goes. I'll stick a bracket around that. It's going to be 1/5 times 2 to the power of 5 plus 1/2 times 2 to the power of 4. Subtract 1/5, add 1/2. I should get a really weird decimal. Oh, not that weird. Hit the math button. Option 1 turns my answer into a fraction. And so eliminate the chances that I make a mistake. So this double integral has the value of 137 tenths, which is fine. Makes sense that you may get an answer, something like that. Are we good? Any questions about that, or does it seem, as a process, it seems to be fine? Right. Now, there are going to be, as you might expect, all sorts of nuances and slightly different ways in which this particular question could be asked. So let me show you, same question, but it might be written like this. They'll tell you the function, and they'll have a region, and the textbook likes to call these regions D. I guess R because it's rectangular and D because it's not. I'm not sure why that particular letter. would you say that this information with that would eventually generate this? Can you see how you could transfer that into this integral? And do you see the x going, oops, sorry, let's be connected. The x is going from 1 to 2, and the y is going from 1 to y x plus 1. And that's one way of doing it. Yep, strongly. Oops, sorry. Pretend I didn't draw that picture. I'll try that again. The x's go from 1 to 2. The straight line looks something like that. So you're going to go from y equals 1, which is basically here, to that curve there. So that shape there would be the equivalent to this information. Now, what else can I do to muck about with it? Well, do you know how you have z equals 2x squared y, which is the same thing as saying f of xy? They could do that. They could even do 2x squared y minus z equals 0, because they felt like it. They're all the same guy as far as the function's concerned. The region could be given in terms of this fella. The region could be given in terms of a picture. So you can imagine there's quite a few permutations going on about what that looks like. So let's just focus on the first kind again. So let's see, what kind of question can I use here? This is similar to question 2. The integral is from 0 to 2, from 0 to y squared, and the function is x squared y. Is that almost identical to the one I just did? It is. Let's not do that one. Let's do something like 1 then. It's the integral from 1 to 8, the integral from 0 to x, 5x take away 2y, and you're going to do a dy, you're going to do a dx. Okay, we can do that. It's going to be the integral from 1 to 8. By the way, these are y equals. With respect to y then, that guy's going to get me 5xy, and this guy's going to get me minus y squared. We're going to then evaluate it at 0 to x. And you plug in x here, you get 5x times x, which is x squared. Take away an x squared. Minus, you plug in 0 here, you get a whole load of nothings. So there's going to be that guy. Can I dot that? You can imagine, isn't that just a, what's 4/3 x cubed evaluated at 1 and 8? Couple of things to know about non-rectangular regions. They always have this shape here. This has to be numbers. It may be numbers in terms of the x values. You could switch places. It has to be what values in the y. You are never going to set up an integral where either of these have an x or a y in them. It just ain't happening. This one here if it's non-rectangular at least, this will have a variable in it, at least in one location. Sometimes in both places, but at least in one. That's a truism about all these questions. Next.
So just to rephrase that, the first integral will always have bounds that are numbers, or the outermost integral will always have bounds that are numbers, but the innermost will have a variable somewhere.
Yes. Now, imagine I just gave you a general version of a non-rectangular region, right? Like this. Doesn't matter if you do X or Y first. Typically, these would be separable, wouldn't they, if it was rectangular? You cannot separate non-rectangular regions. So the shortcut that we used for rectangular regions, right, where you could break it into two separate integrals, make your workload a little bit easier, is not ever going to happen in non-rectangular regions. And the thing that kind of stops it is this variable here. You know, the innermost one, as you described it earlier, that is going to have some variables in it, and that tends to need the entire package there for the substitution in. If you don't have that entire package there, it just doesn't come out right, essentially. So you have to pretty much ignore most of the shortcuts that we could get away with in the rectangular regions, and we can't do anything as nice as that when it's non-rectangular. Now, let's just scroll through and see if I can find something interesting. This is interesting. Didn't take long to find one. An integral from s equals 0 to s equals 1. An integral from t equals 0 to t equals s squared. And the function, it's kind of what caught my eye, is that one. So the variables are called s and t instead of x and y. That's not really a biggie in math. If we do the usual strategy, be careful here. What is the antiderivative of the cosine of s cubed? Be careful.
T cosine s cubed.
Great. Just like having 5 gets you 5t. Isn't cosine of s cubed basically considered a constant if we're integrating with respect to t? Now, when we start plugging in our numbers now, let's see what about our variables, I guess. We're going to get s squared, the cosine of s cubed, take away nothing. And so that's what we're left with. Now, what technique in Calc 2 do you use to integrate that ugly bugger?
U sub?
Correct. And who would the U sub be?
S squared?
Or?
Oh yeah, it will be s cubed.
S cubed. So let's take it a little bit further and see why that helps. A little line. Differentiate with respect to s. I have to put little funny marks on my s's because they look very, very like 5s if I don't. So if you're wondering why I'm doing that, that's why. Crossover. Divide both sides. In this case, 3s cubed. To isolate the ds. So we go over here, ignore the limits of integration, and I have an s squared, at least for a few moments, cosine of u, and the ds becomes 1 over 3s squared du. The s squareds cancel, and we get that. Now, you notice that in these two, I haven't put the limits of integration, which are from 0 to 1. The reason I haven't put them in is that there are two approaches, both work. One approach is find out what that answer is, convert it back to s cubed, and then put the limits of integration in, which tends to be the way I do that. But there is another way you can do it. Can't you use this formula to change the limits of integration? So when s is 1, won't u be 1 cubed, which by sheer coincidence is 1? And when s is 0, won't u become 0 cubed, which is 0? So you could do it in terms of u. I tend to not do that. So you integrate with respect to u. You convert back. And then at this point, I put the limits of integration back in. A very pretty answer. If you plug in 1, you get 1/3 the sine of 1 radian. And if you plug in 0, the sine of 0 cubed is sine of 0, which is 0. So basically, that's the answer as an exact value. Can you see that Calc 2 techniques, in this case U subs, are kind of important because you're going to get questions where that would happen. Imagine a different question, but you ended up with this integral. It's not that different, right, from this one. But you got this one. What technique would I use to get that integral?
Integration by parts.
I would have to do something like that. So you got to be aware that in different, very similar looking circumstances, different techniques have to be used. Right. So, are we okay with question 4? Can I move on, or are there any questions about question 4? Just kind of scrolling through, seeing what we got. Okay, let's do one where the information is given to you in a slightly different form. A double integral over a region D. That guy. And the region D is described as a set of all points such that y is between 1 and 2, and x is sandwiched in that way. Now, when the information is given in the form of a region described in set builder notation, we have to take this information because it has a lot of things in it. Not only does it tell me the limits of integration, it also tells me indirectly which variable to integrate with respect to first and which one second. Because there's a choice here. Couldn't it be dx dy? But it might be dy dx. And the choice is being made for us here. So, do you see how these two are numbers? They have to go on the outside. Do you see how this has a variable? It also helps me because this transfer is a little bit more natural. If I put the y equals and the x equals, for me it helps. Now, all I've got to do now is decide dx dy or dy dx. And only one of them is right, agreed? Who goes first? X or Y?
The X.
Correct. Tell me why, or how you know.
Because the D is restricted by that. That's the one that we have. That's the variable.
Right?
Yeah.
X is here. Yeah.
Should the bounds of immigration be switched for the X's?
Oh, well caught. Small, big. Small, big.
Perfect.
Do you know what would have happened if I'd done it the way I'd written?
Would it come out negative of what it should have
Yeah.
been?
Yeah. So, not that that would be a good thing to do, but at least I would know. Right. I really don't want to do this one. Would you agree this one is a pretty standard kind of power rule? There's nothing really that weird going on. So I don't think I would give you much benefit by doing that one. But it was nice to set it up. I think that was useful. Let's go and scroll a bit further, see what's in. Okay, this is version of question 8. You're given a double integral of y, and the region is D, so it's very generic. And D is bounded by y equals x take away 56 and x equals y squared. So there's going to be some kind of region generated by this, and it's not that clear, I don't think, yet, what this region is. To save time, can you trust me that if you put equation 2 into Desmos, that's what x equals y squared looks like? Can you imagine? I did it. I'm just doing it for speed. Now, the line y equals x minus 56. Well, it's a straight line and it starts here. So imagine that's negative 56 and it would go up something like that. So they're talking about a region bounded by. A region bounded by typically means the region that's made up of, for want of a better word, this piece here, the banana shape. Would that make sense? That is the region D that they're asking us. Now, I needed that picture. There's no way I could look at that and build the guys that I need, right? And you might say, well, who are the guys that I need? The guys that I need are x between this number and that number, and y between these two functions, or the other way around. So I'm going to look at this function and I'm going to decide if I'm going to do it, describe it in terms of the x's, or am I going to describe it in terms of the y? And if I look at this particular one and you go this way here, then all I need to do is I need to find what the coordinate of this point is and what the coordinate of that point is. And won't that be my start and finish for my y values? And won't x go from here to here? And that will be my other guys. So I'm going to be able to say y is between this number and that number, and x is going to be between here and here. Well, let's do the x's. If you rearrange this equation, won't it be the same thing as x equals y plus 56? And on the smaller side, it's this guy, and won't that be x equals y squared? Are you comfortable about how I got the boundaries for x in this question? Horizontal from here to here. This guy is an x equals y plus 56. This curve is a y squared. all my little rectangles. Start it here and finish it here. So all I need to do now is get those two numbers and we are done. How do you think I'm going to get those two numbers? In other words, the y coordinate of this intersection point and the y coordinate of this intersection point.
Just set them equals to each other.
Right, so algebraically, couldn't I just set them equal to each other, like G said? So what would that be? If you use this version and you match it with this, you're basically saying that this guy equals that. A little rearranging. Probably factoring. 7 times 8, which gives me a y equals 8 and a y equals -7. So I know this isn't to scale, but who cares? It's correct. Now, if you go to Desmos, can't you? Won't Desmos tell you the coordinates of these points if you make your window the right shape? So I now have my integral. At least I now have the information I need to set it up. It is going to go from y equals -7 to y equals 8. It's going to go x equals y squared to x equals y plus 56. The function is still y, and the order is going to be x's and y's. So it's going to be dx, dy. And that is how we set up this particular double integral. Have you noticed that there's a lot of work in setting that up? I haven't actually answered the question yet, I've only set it up. But from this point onwards, it's a little bit more straightforward. And I want to do something, because I think I probably, if you can bear with me, I think I should probably have done that on Desmos, because I'm saying, can you believe me and can you trust me and all that? And I think it would be helpful. I'm just getting Desmos set up right now, so if you're wondering what the heck I'm doing, that's what I'm doing. Okay, move over here. So you're going to hopefully see everything I just showed. Now, one of the things I can tell by my sketch is that this window is probably not going to be the correct one that I'm going to end up with, but I'm not going to worry about that quite yet. The two guys that we got was x, so I'll do it the way the book had it in the question. It was y equals x take away 56, which is a straight line that doesn't even appear on this, but we'll fix that in a minute. And then we had an x equals y squared, which at least I can see. Now, if I scroll back and shift along, can you see the diagonal line meeting up with the big C? Right, my scales may be a little bit different, but now that I can see that, I think I could adjust this window to just show this piece of information, right? Just what's going on here. So it looks like if I do, oh, what's that? That's 10. 10 to -10 on the y's. It's a little bit nicer. And on the x's, I don't think I really need to go much beyond, well, I want to see the y-axis, so I'll keep that. So how about -10? And let's see, something like 60. I thought I'd fix that guy. There we go. Right, and if I shrink it just a tiny bit, there. Can you see my big happy C in my diagonal line? So we got that picture right. Can you see this is the region that we're interested in? Now, wasn't this guy here -7? Yeah. Now, can you see it? 49, -7. Do you see the y value is -7, like I said? And wouldn't this guy up here be +8? And can you see the y coordinate is exactly what I said? It's +8. So everything I did in my little picture, do you see that's what Desmos is for, right? It's going to sketch it for you. Desmos doesn't care if it's a y equals or an x equals, it'll figure it out. And there's a question that no one's asked me yet, and you might have just thought, well, he picked it because he wanted to. Have you noticed that I only did the rectangles going horizontally? Because I did the rectangles going horizontally, the y values were numbers, right? -7 to +7. And in this shape, horizontal is the only simple way of describing this shape. Let's try what vertical might look like. If I did vertical, wouldn't over here be blue curve to blue curve? And then later on, wouldn't it be blue curve to red line? Can you see that isn't consistent? That doesn't give you a start and a finish that's the same all the way through. The same all the way through means one bit is from one of the things, the curve, and the other bit should be from the other thing, in this case, the straight line. So you need a curve, straight line, match. Well, in this case, there we go, curve, straight line, curve, straight line. So it's not trivial what direction you decide to do your horizontal scales, or your horizontal slide, whatever you want to call it, or you want to do the vertical one, right? If you're really lucky, in some shapes, both are fine, right? Both work, right? But in most shapes, I would suspect that it's more likely one direction works and the other direction fails. I don't know if that helped, but it kind of helped me verify that I did it right. So you know you're going to be a Desmos fiend by the time you finish these questions. You'll be able to take a shape and play about with Desmos, and because you have to do the windows, right? They don't always give you a decent window. You have to play about with it. But eventually you got it. Right, now we got to here. I'll pause a minute. Are we comfortable how I took the information and created the picture and found the start and finish and eventually got this integral? Are we comfortable with what I did to get to there? So now our question really becomes integrating this all.
So now what happens if we decided to do the y's before the x's in the actual integral? Does it matter which way we would actually figure it out?
Oh God, yeah, it does. It does actually matter. Let me show you what it would look like.
Because I know you had said before the order of like how you write, like if it was the x is equal to y plus 56.
Rectangular doesn't, yeah. Sorry. I just interrupted you there.
Okay. I just didn't know if like we understood the format if we wrote it one way but we solved it the other.
You wrote it one way, but you solved it the other.
So like if we're solving it and we say that the double integral is x is equal to y squared and x is equal to y plus 56, and then take the integral of y, -7, y 8, y dy,
which is
dx,
what this one is.
But then so if we
right,
decided to write it the way out on the bottom one, but we realized that doing the opposite version, which is the top one, would be better, is it okay if we write it like the way it is on the bottom and then solve it the way it is on the top? Rewrite it and solve it the other way?
That would not be a good idea.
Okay.
So I would say no, don't do that.
Okay.
If you look at the way I've written that, and you might be saying, well, I'm going to write it that way, but I'm really going to calculate it this way. Well, you might as well write it the way you're going to calculate it to be consistent in math. Okay. If you try to do it this way, you could certainly get a number out of that. but won't you end up with variables in your answer? Right. Let's pretend I did that, right? And let's pretend the answer was 10, because it'd be a number of some kind. What you would now do is you get 10x, right?
Mhm.
And x would get replaced by these two. Can you see that your answer would end up being some function of y's? It wouldn't be the area, or it wouldn't be the value of the double integral, which is a number.
Yep.
It would be some wrong expression.
Okay.
So the short answer is there's only, when you set up a double integral and you set it up in this format, then you kind of have to do it in order. Now, there's another different question where, suppose the region, I decided to describe the region by doing verticals instead of, in this case, doing horizontals. That region would create a different double integral. And the integral would be y's in terms of x's and x's with numbers, and you do a dy first and a dx end. That integral would look quite different from this one. But at the end, the answer would be the same because it's generating the same thing, right? It's generating an area moving upwards onto a surface. I'm not sure if that's kind of what you're thinking about. In this case here, let's do that fella. This fella just basically gets you x, y, because with respect to x, y just is a constant. You evaluate it at these two guys, and that would be here. If you plug in the top one, you get y plus 56 times y, take away essentially y cubed, because that would be a y squared times y. And then what would I get? Y squared, 56y, take away a y cubed. Right, and at this point here, isn't it just a Calc 2 question? And it'd be a power rule. And you get whatever you got, right? And that would be good, because that's what you need to get. You're looking for numbers. If you ever do a double integral and there's x's and or y's, you've probably made some mistake somewhere that you should fix. Are we good?
So you would solve that. That integral that's -7 to 8 times the value dy. So you'd still have to integrate that and then solve.
Yeah,
and
you'd have
hopefully
to
get
do.
42. Okay.
Or I'm making up 42. I'm sure it's not that, but whatever it is. And you get some number.
Okay.
We good? Right. Let's keep going. I've got so many windows open here, I'm losing the place. We haven't done a trig one. Do I want this one? I have no idea what this one's going to be. So it's like 9. I just looked at it and thought, oh, that's kind of cool. It's got a cosine in it. And the D is another one of those bounded fellas. And it's bounded by y equals 0, y equals x squared, and x equals 5. Now, I could certainly put that into Desmos, but I'm only going to do this question up to the point where we've set up the double integral. So let's see what we get. If someone tells me the line y equals 0, which axis is y equals 0?
The x-axis.
Okay, so that means one of the boundaries of this area is that x-axis. Now, y equals x squared is basically a curve that looks like this. And x equals 5, isn't that a vertical line at 5? And so Now I know the region that they're talking about. Would you agree that these three things generate this region? This is D. Okay. Now, I could build this shape using verticals. I could build this shape using horizontals. Wouldn't both work in this case? Can you imagine a random vertical rectangle? Wouldn't it go from here to here, here to here, here to here? No problems. If I did a horizontal one, here to here, here to here, here to here, no problem. So in this case, as long as you set up your integral the right way, you will be able to get it in two distinctly different ways, but the final answer will be the same. Okay, do you want me to go with the vertical rectangles, which means x is going to go from 0 to 5, or do you want me to do this one as horizontal rectangles, in which case I'll show you what we would do there. Which one do you want?
Can you do this horizontal? I feel like that one's a bit weirder to set up still.
So if we're doing a horizontal, I just randomly put a guy here, right? Little invisible dotted line here at 25. And what that would tell me is that the y's, these rectangles, slide from 0 position, y at 0, and they finish at 25. So I now know that the y's go that way. Now, this point here and this point here are the start and finish of my rectangle, and they are going to be the range of my x's. The biggest one goes on this. Would you agree that in this side, the x is 5? And on this side, the x is whatever that curve is. Well, yeah, it is what that curve is, but it has to be the curve given in terms of x equals. So instead of y equals x squared, I'm going to do x equals the square root of y. So that would get me that fella. Technically, couldn't it be plus or minus the square root? But it's obvious that it's positive in my picture, so that's why I chose that one. So my double integral, if I use this fella, would be y equals 0 to y equals 25, x equals the square root of y to x equals 5, and the function is 5x cosine y. But if I do it in this order, won't x's and then y's? And since we've got enough time, it's going to be a really messy picture, but I'll try my best. Let's suppose we do it the vertical ones, right? Now, in the vertical ones, don't those rectangles scan from 0 to 5? So what that tells me is that x is going to go from 0 to 5. Now, what's that rectangle going to look like? Well, it has a top, right, and has a bottom. The big value's on top, the little value's on the bottom, so I know y is 0. And isn't the top the y guy in terms of x? So it's x squared. Right? Y equals x squared. And that becomes the integral from x equals 0 to x equals 5, the integral from y equals 0 to y equals x squared, and now we have a 5x cosine y. We're doing y's first, and then x's second. Now, if you look at those two, they will eventually get you the same answer, right? But apart from these formulas, which have to stay the same, aren't the limits of integration distinctly different? So I'm not like, you know, in the rectangle, you just switch the order, but the numbers stay put, right? A 0,3, a 0,7 just turns into a 0,703, right? Nothing really happens. Can you see that if you change the order of integration, right, because you looked at your picture and you did it in two ways, do you see there is a very definite difference in what they look like? Now, although both of those theoretically are possible, and in many situations in practice you can do it both ways. Sometimes one of them don't work. And the reason it doesn't work is because the integral is something that's really hard or impossible to do. Whereas the other one gave you a really nice, easy one to do. Okay. So I guess the question is, have you any gut feelings about which one of those two might be the easier to do?
I think the one with vertical rectangles would be easier.
Right. So if you kind of get that gut feeling, go with that one first. It won't take more than a couple of lines, maybe just one more line, for you to go, okay, that was a bad idea. I'm not saying it is a bad idea, but you might come across it and say, I don't want to keep going. Well, what you can do is you could just pause there, go back to your picture, and maybe go horizontal. One of the two has to work or the question's not fair, right? One of the two has to be doable. And a little bit of Murphy's Law kicks in. You know, if there's two ways to do it, you only do one, right? Isn't the one that you do first probably the wrong one? Well, for me it is. And so that's okay. You do it their way. In a perfect world, wouldn't both work and it wouldn't matter? You know, it doesn't matter if you go horizontal or vertical, both versions work and they're equally easy or equally hard. That would be a perfect question because then it wouldn't matter. Okay, I think we are finished for today. So say hi, get your attendance. I think we learned some cool stuff today again, didn't we?
We did.
It did. I like things like this because my brain, I'm a visual learner. I'm a horrible drawer. I've never been an artist. But I can visualize things. It's scary to try and describe people. But I can, sometimes it's like a projection. I see it in my mind, but it's almost like visual. And I can look at things and I can just imagine. I can't draw it very well, but I can imagine, you know, the shape going up and having a funny little curve and the area below and what it would look like. And it's satisfying. My brain gets pleasure out of that. Yeah. But hopefully you do as well. It's cool stuff. Lindsay?
Thank you. Have a good weekend.
You are welcome. You too. Have a great weekend, guys. I'll hang about if there's any questions that you might want to go over. Apart from that, you know, don't wait till a section's finished to start doing the homework questions. You can look at the questions in this section and you should know the ones you can do because we've covered them. And you should also know the ones that I haven't a clue what that's about. That's because we haven't covered it yet, right? So you can skip those until you get to it.
I have a quick question, Professor.
Yeah.
I was informed on the next Tuesday I won't be able to attend class. I will be out on the field. They have me doing an engineering job on the field that day. So
okay.
I won't be able to attend
Well,
class.
thank you for the heads up. Keep your eye open for the video. Watch the video.
Okay.
Hopefully that'll be enough. I don't think anything particularly special happening on Tuesday. Just a typical lecture day. But
And then
thanks
I
for
was
telling me that.
wondering if after class on Monday, we could go over my test.
Sure, I can go over it right now, but whenever you want, that whatever suits you, I'm cool with that.
Monday would
So
be
Monday after class, perfect.
Yeah. That's all I have.
Right, bye-bye.
Thank you.
Eleonora, Anna, are you hanging about because we have questions? I'm assuming.
Yeah, I have a question on the 15.1 homework, number 14.
Okay, is it something you could read out to me or will I have to go looking for it?
Oh, no, I have it up right now. It's find the volume of the solid in the first octant bounded by the parabolic cylinder z equals 16 minus x squared and the plane y equals 1.
Okay, what question was that?
Number 14.
And it was from what section?
15.1.
Right, I think I might need more information, so I'm just going to go and look at that. If I accidentally close this window, which I do not intend to, I'll see you in the, oh, it's gone and logged out, okay. Then I'll see you in the officer link instead. But I'm not intending to do that, but
All right, sounds good.
I'm playing about here with dynamite. I could hit the wrong button any minute and blow the thing up.
Yeah.
Just take me a few moments. It timed me out, so I couldn't just click on it. Where are we? Come on, come on. There we go. And it's section 15.1, which is double integrals, which you would expect. Put it on view. It's question 14, which makes it the second last one. I don't see anything specifically different from what you just said. Put it on a solution. And a key. Give me a clue to anything. Did you get an answer that didn't work, or did you get an answer that, or you couldn't get an answer, I guess is what I'm asking.
Yeah, I wasn't sure at all what to do because I wasn't sure how to find
Gotcha.
the limit.
Should be ready now. I'll put question 14. Oh, it never did that. Oh, okay, that wasn't what I was expecting. Okay, so oh, I get it now. My question 14 is not yours because it randomized it, and that is just what it does. So show you what its solution looks like, then I'll try and explain where they're coming from, though the numbers will have to be adjusted. Right, so I enlarge this. Okay, so z equals 16 minus x squared, right? If you look at where does 16 minus x squared, what does that cylinder look like on the xy plane, on the floor? Then what you are getting here is, what are you getting here? That does not make sense. Oh, I've got my function, okay. That makes sense. So I guess my problem is, where is the rectangle? Well, I know I've got y equals 1.
Mm-hmm.
I don't like their solution because their solution's not what I would have done. And I'm trying to find out why their solution's not mine. Essentially, I'm looking at this z equals 16 minus x squared. And I notice that when you do z equals 0, what you get is x equals 4 and negative 4, which would give you your x values. And the y values you just get from the 1 that they gave you, so it would be 0 to 1. So my answer is not theirs, and that's what's bugging the heck out of me. Why would that not be the case? Okay. Oh, darn in space. Okay, I know what's going on now. I can show you.
Yeah.
There was a word in there that I didn't notice. It was called the first octant.
Yeah.
Did you see that word?
Yeah. I
First
did.
octant. Yeah, you can remember in first, second, third, fourth quadrant. That's what we name them in 2D space. But when you do 3D space, there are 8 regions called octants.
Okay.
On the top, there's 1, 2, 3, 4, and underneath are 4, 5, 6, 7, 8. When they say it's the first octant, they basically mean that guy.
Okay.
Now, if you take this cylinder, right? So can you imagine this is a cylinder, right? If you take this cylinder and it comes down and it hits the XY plane, isn't the XY plane Z equals 0?
Yeah. Okay. Oh, I see.
And
I
it's
get
Z
it.
equals 0, you get that, which means you get that, which typically would be plus and minus 4, but because it's in the first octant, it's only 0 and 4. And then you get Y equals 1. Well, yeah, it's Y equals 1, but because it's the first octant, it's also 0 to 1. So there is that hidden rectangle.
Okay.
And the guy that you're going to do it to is this fella.
Mhm.
And you're going to do it, well, it doesn't matter. You can do it dx, dy. If you do it dx, dy, you go 0, 4 and 0, 1.
Okay. I see now.
Right, so it's very cryptic, and the word first octant was more important than it seemed, which is why I was getting so confused, because I didn't read the question carefully enough. Is that it? You have another question?
Yeah, I think I can get it from there. Nope,
Okay.
that's it. So
That's it.
thank you.
You're welcome. Anna, you got a question?
I do.
Hopefully it was that
I'm
question.
confused on how to do the integration. It was not that question.
Darn it, okay.
And number 6 on 15.1, I'm confused on how to do the integration by parts. I reviewed some of my notes and I understand the concept of how to do integration by parts, but it's just not clicking.
Right, so my question 6 from 15.1 is, let's check I'm on the right section here. Yes. Okay, my question 6 will be a little bit different numbers from you. Do you have your question handy so I can do it with your values to make it a bit clearer?
Yeah, I do. So it's the integral from 0 to 3, and then the integral from 0 to 1 of 2xy times the square root of x squared plus y squared dy dx.
Now, because of this, it's not separable. You can't separate them into 2 separate integrals, right? So we're going to have to keep it as is. So I'm going to try, well, not try, I'm going to integrate this fella. And you were saying integration by parts, right? That's what I heard. It's not integration by parts, it's a U sub.
Is it?
Yeah. So let's show you the U sub. I want to integrate with respect to y. I'm going to make my U sub x squared plus y squared. And I am going to remember the x squared is just a constant right now. So I don't want that to get, in the way of what we're about to do. Now, we differentiate. Technically, it's partial derivatives, but we're doing it this way. We're differentiating with respect to y, which only gets me 2y. Can you see the x squared doesn't count because it's a constant and I'm differentiating, right? Now, we're cool, right? Okay. Next step is we do what I call the crossover, which is that. And then you isolate the dy. So I'm going to go over here And I'm going to call this guy 2xy, the square root of u, and instead of a dy, 1 over 2y du. The y's and the 2's cancel, and I'm left with x square root of u du. The square root of u will be called a half power. I will then do the power rule on it. And I'll leave it like that for a second. I will then return that guy to be this fella. And that becomes 2/3 x, the square root of x squared plus y squared, all cubed, evaluated at y equals 0 to y equals 1. And all those x's that I've not done go there. So I'm now going to do the integral from 0 to 3. If you plug in 1, you get 2/3 x, the square root of 1, which is what, x to the 6. Take away 2/3. Oh no, x, take that back. X squared plus 1 cubed. X squared plus 1 cubed. Take away, you plug in 0, you get 2/3 x square root of x squared cubed dx. Wow, this is ugly. What can I do? 2/3 x, the square root of x squared plus 1 cubed. Take away, this guy is x to the 6, square root of x to the 6 is x cubed, 2/3 x to the 4 dx. And that's us taking care of the y's. And it was a really, really ugly use up. Now, this is easy, power rule. How do you think I'm going to take care of this fella?
Another u sub.
And be careful, who's the u sub?
The 2x, or no, sorry, the x squared plus 1.
Yeah, and it'll be